Hello everyone, my name is Vijay Kadkol and I'm from Utthunga Technologies Private Limited. In this session today, we're going to learn about uOPC PubSub. uOPC PubSub is a flagship product from Utthunga. It has spreadsheet-based configuration. A configuration will help run the PubSub bridge itself. We'll also see how to configure PubSub through APIs. And this is best in case if it is running as a framework. And it will be followed by a demo. As the name suggests, the participating applications for PubSub can either act as a publisher role or a subscriber role. PubSub is a decoupled architecture. That means any number of subscribers which are fetching data from the publisher will not have any influence on the publisher. And that's the reason why this model is best fit where it is location independent and which needs scalability. PubSub collects data from different data sources and presents it in an OPC-UA PubSub format as defined by Part 14 of OPC specification. It will be fed into IT and cloud applications to ingest data. The publisher component can publish data to an OPC-UA message broker. The data flow from publisher to subscriber is orchestrated through a message broker. In this case, it could be an MQTT or AMQP. uOPC PubSub supports both. Subscriber can pick the data from the broker and write it back into OPC-UA sub. So that completes the publisher responsibility and the subscriber responsibility. Common use cases where we have seen uOPC PubSub usages are connecting process data to IT, enterprise, and cloud. Majority of the use cases where the industry want to publish the data for analytics so that it is easily available to analyze or derive certain pain points or how the behavior of the system is. So uOPC PubSub is a best fit there. It acts as a DMZ gateway across domains using OPC-UA PubSub mechanism. One of the common scenarios we have seen in ITOT layer is data between the process sublayers have to be transferred through a secure channel. And OPC Bridge, uOPC Bridge is a best fit because the data can flow through a message broker and it can have a point-to-point connection. It can be also used in connecting OPC-DA data to cloud. Majority of the deployments to date are on OPC classic DA servers. And if you want to take the DA server data to cloud for analysis, then uOPC PubSub is the best fit. It also enables loss-free transmission over noisy connectivity link. It has a built-in feature where it can store and forward data on different logger modes. It also acts as a protocol bridge for underlying data sources. The best example for this is uOPC PubSub Bridge has data source connectivity with Modbus TCP and Modbus RTU. Before going on to the demo setup, let's have a quick look on how the spreadsheet configuration looks like. What you see is a configuration XLSX, which is fed into uOPC PubSub Bridge. Let me make one point clear that during a production environment, you do not need any licensed version of spreadsheet reader, especially Microsoft Excel licenses are not needed. You can either use to have any freeware spreadsheets viewer and editors to configure this spreadsheet. PubSub, uOPC PubSub Bridge does not include any or does not expect any licensed version of the spreadsheet like Excel itself. With that, let's try to understand how the spreadsheet looks like. The first sheet here defines the message brokers. On column C, you can see that we have configured it for MQTT. And the topics on which we will see the data in MQTT is OPC-UA 1, OPC-UA 2, and OPC-DA, and Modbus. You can also see that which is connected to a local hosted Mosquito broker, and it is secured through username and password. Password, however, is masked in the configuration sheet. Let's move on to the second sheet here. Data set. Data set is a logical grouping of data from different data sources, which can be visualized on to a particular topic. In this case, we have configured 4 different data sets: OPC-UA dataset 1, dataset 2, OPC classic dataset, and a Modbus dataset. Let's come back to dataset item at the end. It can be more visualized through a slide. For OPC-UA server, we have configured 2 servers. We have a Kepware server running locally and a simulation server which is secured through security mode as sign, security policy as basic 256 SHA 256, user identity type as username password, and you can see that we have credentials provided. Password, however, is masked in the configuration document. Even this avoids any accidental viewing of the password in the configuration document. OPC classic server configurations. We have a softing server which is running locally for classic DA data. For Modbus configurations, we are using a mod RSIM2 simulator, and we are using a TCP channel to publish data and subscribe as well. In this sheet, we are only defining the Modbus device with the various configurations. We can also provide Modbus tags. In this case, we have provided 3 holding registers, TCP1, P2, P3, which are uint16 data type and with access level read write. TCP channel is hosted locally on a port 502. So coming back to dataset item, this can be best visualized through the slide here. We have 2 major use cases for uOPC PubSub Bridge. It can be used as publisher only. In the second use case, it can be used as publisher and subscriber. That's why out of the use cases what you see on the screen, few have a subscriber and few don't. In the first case, OPC-UA server from Kepware with tag 1 has to transfer data and write it point to point to Modbus device TCP/P3. In the second use case, we are publishing the data from a process which is a secured line in 32 data item into message broker. In the next set of use cases, OPC classic server has a publisher subscriber scenario, and where I2 node is writing data into uint16 data item of Kepware server. We get pardon. It's a process OPC-UA server. And in the next use cases, it is publishing data from UI2 unsigned int, basically UI4 as well. For the Modbus dataset, we are publishing data from register P1 into OPC classic softening server UI8. And the last use case will be pushing data from P2 into message broker, and it has no subscribers. Yeah. On an overview, you can see that the data is being transferred from the left side servers, which are publishers, through message bus into MQTT Mosquito broker and then to the subscriber. The locks indicate that they are secured lines. Now, let's understand how API component works. What you see on the screen is a Postman tool, and I have chosen few of the APIs which are relevant for this demo. I'm basically authenticating the communication between the API and the PubSub Bridge, which is secured through JWT token. And we're able to stop the services of uOPC Bridge through APIs. This is best suit when we are trying to deploy the PubSub Bridge through as a framework and has very less or no manual intervention, should be controlled directly from the APIs. In this case, we are able to add OPC-UA servers. I'm able to upload the simulation server. This is very important when it is a secure channel, that we exchange certificates between the communicating entities. In this case, it would be process, OPC-UA server, and PubSub Bridge. Same thing has been done on the OPC-UA simulation server as well. You can see that we have trusted the OPC PubSub certificates. We are able to add OPC classic servers, Modbus TCP channels, queues, and dataset items. In fact, the spreadsheet which you just saw is created from these set of APIs. Now let's go on to start the service. In fact, it's already started. Let's understand the use cases, and we'll take one at a time. So in the first one, we would like to see that tag 1 data is being pushed to Modbus TCP 3. So let me unsubscribe for all the messages. In this case, I'm interested in OPC-UA 1 topic. Let me bring up the UA expert. I probably have to give an introduction of the tools which I'm using. I'm using a softening server. I'm using a process simulation server. I'm using a UA expert to visualize the data as a client, OPC client. I'm also using a mod RCM2 simulator. And I'm using MQTFX to visualize the information in the Mosquito Broker. And I'm using a Matricon OPC Classic DA client. Now, in the Mosquito MQTFX connections, let's understand the fact that this line is secured, as mentioned in the diagram, that it is controlled by user name credentials. With this, let's see how the PubSub is working. Now, with the first use case, I would like to see OPC-UA 1 topic, where the data from Kepware server is pushed to Modbus register. So in that case, I'm trying to open 3 screens simultaneously. You would see that the data on tag 1, when I would change the value in the message broker and then update the register 3 on top here where the mouse pointer is. So let me try to do that. I changed the value to 233, and you would see that the value in the message broker has been updated to 233, and the same is updated into TCP3. Yeah, I updated the value as 789, and you would see that it has flown from message broker to the register 789. Sorry, register 3, the value is 789. So that is for use case 1. The second use case, we are trying to publish the data from secured process OPC-UA server into message broker. Let me unsubscribe for this topic. Let me subscribe for OPC-UA 2. You would see that the data 123 is getting updated. I've changed to 566 and it gets updated into message broker, and you see that the message keeps on coming as per the publishing intervals which is configured in the spreadsheet. Changing it to 34, and there you go. It's getting updated into message broker. In the third use case, we would like to see that OPC classic server I2 tag or node will update the value in OPC-UA server U in 16 data item. Let me bring, for a better visualization, I have to show all screens in one frame. So now you would see that I2 data is constantly, I need to show you a export. Yeah, I2 data is constantly updating the value in the message broker into the subscriber here, the highlighted line. Yeah, it first updates the message broker and then comes to the subscriber. In the next use case, we are publishing data from UI1, UI2 and UI4 into message broker. So for this, let me unsubscribe from DA. I think I have to show back the information of the previous use case. Data from I2 updates the value into the message broker I2, and the information flows to the highlighted value here. Yeah. Let me show the next use case where informations of UI2 and UI4 are just published. Yeah, the values are getting updated into message broker. In the next set of use cases, I have Modbus data, transfer data from TCP1 register to classic server UI8. For this, I have to subscribe to the topic Modbus. Yeah. I'm going to update the value in the simulator. (434) updates into the message broker and then updates into the subscriber. Should I do that again? 38 updates TCP1 38 and then updates to the message subscriber as well. In the next use case, we are publishing data from register 2 into message broker only. So this satisfies all the scenarios. So the intention of this setup was to demonstrate that we can use uOPC PubSub both as a publisher subscriber and publisher only. Yeah, thank you. This is all I had for this session. Thanks for being connected with me on this. See you in the next tutorial.